So as you said, I'm a professor here at Boise State University, and I'm in the Department of Chemistry and Biochemistry. And I'll tell you a little bit more about my science background in a bit, but I was trying to think, I struggled a lot with, in fact, I regretted the day I said I would do this talk. It was tough for me because I thought, I'm going to walk into a place where I'm going to have people who maybe will be threatened by what I say from those who are in my church and who believe, follow Christ, they're Christians or otherwise believe in God. They'll hear what I say and they'll find offense to it. And then if there are people here, my colleagues, anybody who is a scientist, they'll hear what I say, and they also might be a little ticked at me too. So I thought, man, I'm stuck between a rock and a hard place. And so it got me thinking. I thought, part of the problem is I think people have ideas in their mind what science is and what faith is and sort of preconceived notions, or maybe they're developing those notions now, but we all get our information somewhere, somehow, and we believe things maybe because our parents told us something or a teacher told us something, or sometimes we choose not to believe things because of a bad experience we had. It may have nothing to do with truth, just with your experience. And so I thought, you know what? I'm going to draw the line. Science is not evil, and faith is not stupid. And they can actually work together. I don't see them opposed to each other. And so what I need to first do is kind of explain to you what I'm not doing. I'm not going to debate evolution versus creation. First of all, I would lose. I'm a terrible debater. You'll bring up your point, and maybe 5 days later, I might have a rebuttal. And then you'll say another one. It'd be a really long debate. And there's an art to debate. There's an art to argument. There's ways you can throw people off and chase them down a certain pathway. And I go down every pathway. That's my problem. And not only that, I think I would probably draw fire from both sides of the debate. So I'm just going to not really make this talk about that. The other thing I can't do, because it's a check my brain cannot cash, is I can't prove the existence of God in science. I just can't do that. And so what I will do is kind of tell you a little bit about my background, my story, and how I've come to see science as a means to better understand God through His creation. And in that, I'm already saying some things that will kind of help you understand a little bit about my background. I thought, though, one of the things I love to do as a chemist is play with chemicals. And so I thought I can't pass up the opportunity. Safety glasses, see? I have one of my students here, Denny, and I told him I'd make him explain some hydrogen bonding or something like that. And he goes, really? Well, maybe I will, because I think you can do it, but I won't. I promise. So I have a mason jar here, and I have some other chemicals, and hydrogen peroxide. And really what I want to do is just, one, I want to show you a really cool chemical reaction. And it's one of my favorites, and I can be silly. That's part of my nature. And I like to do things like, I like to engage the audience, and so I'm going to do that, if that's okay with you. Have you ever witnessed or seen some aspect of the wilderness around you and thought, man, I wish I could do that? Maybe it's a fish, a swim. So could I have some examples of what kind of animal would you wish you had that trait? Something that inspires you. Bird.
Yes.
Bird? So you can poop on people's heads? I'm with you on that one. What else? Any others? David, I just learned David's name, so I'm gonna make him say something to me.
I wish I was a cheetah second row.
You know, when I ask this, people usually say bird first, cheetah second, so
Yeah, I
they
just
can
want to
run
run
fast.
more.
Yeah. And for me, oh, you got one?
Fish.
A fish, yeah. So you can swim, and then I can catch you and skin you. Oh no, that's a different part of my life. So yeah, so for me, I like fireflies. I come from the Midwest, and fireflies are all over the place, and they can make their butts glow. And to me, that's what I'm all about. So, in order to do that, I brought my butt glowing materials. And so here's where, at some point, I'll ask the lights to be dim, because you'll get the appreciation of it when I do this. So first things first, I'm gonna do the chemical reaction. See, that's the thing, when I talk about chemicals, you know, I heart chemicals, I talk about chemistry and chemicals to a lot of people, and I think they get a bad rap. They're pollutants, pesticides, you know, poisons, some other P word that's bad. And the truth is, we're all made of chemicals. And one of the things that I can really appreciate is, since I actually do believe God created the earth, I think he created the atoms and the chemicals inside of me. He made me out of chemicals. I don't know why. I'd love to know why, but I can't, and I don't. So the best I can do is describe some of the stuff we see. But here's some chemicals. This is not urine. Can't tell you. No, it's potassium ferrocyanide, since you asked. All right, and then I just have to mix a little bit of some, just a little, yeah, that's good enough. Very scientific.
Hydrogen peroxide.
A little hydrogen peroxide, H2O2. And then here's where I'll need us to dim or turn off the lights so you can appreciate this. And this, if this doesn't inspire you to want to be a dragonfly, then there's no hope for you. So there's a chemical reaction going on in there, and one of the products of the chemical reaction is energy in the form of light. And that actually happens in the rear end of a dragonfly. Yeah, it'd be better if it was a dragonfly. No, that's true. I often, yeah, you're right, it's a firefly. And the bad part is then there's some other bugs that also can light their butts up, and they attract the mating fireflies, and then they eat them. So that's bad. Okay. All right, so I just thought I'd start with that. It's cool. Now watch what happens when you turn on the lights. So we can turn on the light. It kind of, well, this one's going pretty good. I just made fresh chemicals. A lot of times it'll look more yellow. So it's really going good. I'll leave it there. When it's done being glowing, then I know I should stop my talk. Okay. So, oops. So the first thing I want to do is just show you this really cool video. And I can't, like I said, I cannot provide scientific evidence for the existence of God. The best I can do is show you something that makes me question whether or not there's a creator. Something that really gets me thinking. And so that's really where I'm at. And so I'm going to show you this. If you've ever seen it, first of all, it's science, which makes it cool. But it's narrated by Morgan Freeman, which makes it even better. Okay? So it's called Powers of 10.
Since the universe is a big place, we could easily get lost. So we'll need signposts to give us a sense of scale. The acrobat's ring is 1 meter wide. The crowd is 10 times wider, 10 meters across, larger by 1 power of 10. Now, with every step, every ring, we travel 10 times farther from Venice, and our view of the universe is 10 times wider. The 100-meter ring surrounds St. Mark's, and 1,000 meters, 1 kilometer, the city center. As our speed increases, 4 steps, 4 powers of 10, reveal all the islands of Venice, the Adriatic Sea, and the mainland of northern Italy. Six steps take in Europe from central Germany across Italy to the Balkans. And soon we can see the entire planet, our home in space. Eight steps on our outward journey, 8 powers of 10, and we pass the farthest reaches of human travel, the moon. If we visualize the paths that the 9 planets take in their orbits around the sun, at 13 steps from St. Mark's Square, the entire solar system comes into view. And with 15 steps, 15 powers of 10, we can see that our sun is just another star. From here on, our voyage will be measured in light years, the distance light travels in an entire year. Only now do we fly past our nearest neighbor stars, almost 5 light years away. The same journey at the speed of today's spacecraft would last 100,000 years. As we cross the perpetual night, our voyage takes us up and out of our sun's neighborhood near the edge of a great pinwheel of stars. The Milky Way is actually a spiral galaxy, and our own sun is just one of 100 billion stars in it. At this immense scale, 23 powers of 10, each shining light we see is not a star, but an entire galaxy, composed of countless stars. Astronomers have discovered that the galaxies are flying away from one another. The universe is expanding. Our own galaxy and all the others form clusters and superclusters of stupendous size, hundreds of millions of light years across. And here, about 15 billion light years from Venice, we approach the outer limits of the visible universe. What lies beyond this cosmic horizon, we cannot see and do not know. While Galileo's telescope allowed us to take an outward voyage, another innovation, here in the Dutch town of Delft, would lead us on an inward journey of discovery. Over 3 centuries ago, Antony van Leeuwenhoek perfected the early microscope and used it to study droplets from the waterways of Holland. As students today make their own discoveries, imagine the moment when Van Leeuwenhoek peered through his more powerful instrument and discovered a living kingdom in a drop of water. This busy world of single-celled paramecia is only 1 millimeter across, 3 pounds of tin smaller than a meter. The microscope allows us to continue our journey into the realm of the very small. As we move into the cell nucleus, each new ring now reveals a world 10 times smaller in diameter than the last. Deep within the nucleus, we come upon truly remarkable constructions, long spiraling molecules of DNA. DNA holds the chemical codes for the reproduction of most organisms on the planet, whether they're paramecia, people, or petunias. Voyaging on, we see that molecules are made of even smaller parts called atoms. The tiny world of the carbon atom is very strange indeed. Its 6 electrons seem to swarm everywhere at once. Now our voyage takes us through a void that appears as vast as the space between the stars. Ahead lies the atomic nucleus, so fantastically small that if the whole atom were the size of this theater, its nucleus would be like a speck of dust. Yet the nucleus contains almost all of the atom's mass, packed into particles called protons and neutrons. And these, in turn, are made of still smaller, mysterious things called quarks. Exploring this, the inner frontier of the universe, physicists wonder if quarks might contain even tinier building blocks of matter.
Breathtaking. And little fact about DNA, and this is pretty cool. If you take all the DNA out of your cells and lay it end to end, you would be dead. Okay. All right, so didn't see that coming, did you? So here's the challenge I have. There's me making an explosion. And so part of me, and I'll talk about my faith in a little bit here, I'm kind of, my rock and hard place is I'm in the church. I'm very much committed to what I do as part of the ministries that I belong to and participate in, the way I serve God in those ways. Very important to me, and I have lots of people that I serve with, my brothers and sisters in Christ, and yet sometimes we get conversations, and I try not to talk too much about science on a regular basis anyway, because when I hear people talk, there's a lot of negative connotations that are ascribed to science. It's like playing God. We want to try to figure everything out so that we can, manipulate it. And, I've cloned genes. Raise your hand if you've ever cloned a gene. You did too. And so I was asked, aren't you playing God? That it's anti-religion, that it's against religions, that it's humanistic, that we can figure out everything, and that everything's just knowable, and it can be done without ever thinking about God. And I put in my little joke, evolution, because it's brought up like it's sin itself, the way people talk about it. and it's, people mention, they think of it as heartless. It's just about moving forward, and immoral or maybe unethical sometimes maybe the case, because we can do it, should we kind of thing. And people are worried about what we're doing with chemicals. Should we be irradiating chickens with gamma particles so that they can be sterile? Just raise that issue and I'd have a big argument amongst all of you right here. And then the other part is science. And when I look at, and these come out of my own conversations with my colleagues, whom, by the way, are my brothers and sisters in science, and I care an awful lot about them too, and I respect them, and I think they're fabulous, and I wouldn't want to work with other people. They're great. I'd rather work with them than with the best people in the world. Oh wait, that didn't come out right. So faith in God, then maybe potentially it's a crutch. It's that thing we go to when we can't explain something. It's maybe brainless. How could you believe that? I've been told primitive in that, well, it's easy. If you don't understand it, just describe it to God. And so I actually concede both of these points, and there I am stuck in the middle, and what do I do about it? And that's kind of where I'm at. And so what I thought I would do first is just lay it on the line. I'm going to tell you, first of all, that I relate a lot to this monkey. This is Coco. She was taught about 1,000 words, turns out. And there's debate about whether or not she could truly communicate. Some people think she could because, like, for instance, one of the things she did was she's never taught the word ring, but apparently she made some connections and came up with this combination of signs that was finger bracelet. You might have heard that story. Well, she experienced an earthquake. And when she was asked what happened, well, here's her response. And I got, by the way, if you want the reference for that, I brought my pointer. It actually comes from text that I actually found it. I'd heard other versions of this, so I tried to get to the most original I could. So this is how she described an earthquake. Darn, darn, floor, bad bite, trouble, trouble. Oh, and she painted a picture of it too. And I relate to Coco a lot. When it comes to talking about lots of matters dealing with God and lots of matters dealing with science, quantum mechanics, you don't have to go very far to get me to a place where I really am hurt. And I feel like Coco. I have a limited vocabulary and a limited understanding. My pictures that I draw of molecules and of how things work kind of look like Coco's. My pictures, my words there's going to be times in the moment I'm going to be trying to explain stuff to you, and you're going to ask me some questions, and you're going to challenge me, and I'm just going to be up there going, darn, floor, bad bite. So I'm just telling you where I'm coming from. I'm a work in progress. I am still learning. I am by no means am I a person who has the answers. I actually don't. I'm just thinking. I'm just trying to put things together like most people. And so that's what I want to kind of make that point. So this is probably a more realistic picture of me, and I kind of resemble it. I'm not very intellectual, and that is true. And I'm more of a Three Stooges kind of guy, that's for sure. So here's my beliefs. I'm just going to put it right out there. I am a Christian. I believe that Jesus came to earth and I realize there's all kinds of religions, and I'm not here to dispute one versus another. I'm telling you what I believe. So just so you know where I'm coming from. So this is where I come from. I believe that God sent his son down to earth to die on the cross and take my sin so that I can have eternal life with God. If you don't know what that means, we can talk about it later. And Colossians 1, I read this here, and I thought, so the son that's being referred to is Jesus. And when I read this, I thought, this really is like everything for me. It says, the Son is the image of the invisible God, the firstborn above all creation. For in him all things were created, things in heaven and on earth, visible and invisible, whether thrones or powers or rulers or authorities or all things have been created through him and for him. He is before all things, and in him all things hold together. He is the head of the body, the church. He is the beginning and the firstborn from among the dead, so that everything he might have supremacy, for God is pleased to have all of his fullness dwell in him, and through him to reconcile himself to all things, whether things on earth or things in heaven, by making peace through his blood shed on the cross. Now, I just read that real fast, and for some of you, you know that passage. For some of you, it's just a bunch of word and gibberish. The part I'm going to kind of focus on and where the science comes in here is this whole idea of God being the creator, and that's kind of what I'm going to focus on. Now, I'm just telling you, I believe God created the earth. I'm just going to say it for what it is. Now, here's my background in science. I have my bachelor's degree in chemistry and biology. I have a Ph.D. in biochemistry. I spent many years as a postdoctoral fellow at the University of Iowa, where I studied in the field of biochemistry and enzymology, the study of enzymes, in case you didn't know. And then in 2000, I came here. And I've went through the ranks of assistant professor, got tenure, and associate professor now, and the next rank I can attain, if I ever am good enough, is full professor, and that'll be relatively quick, I guess. My research areas are protein chemistry, enzymology, chemotherapy. I'm a cancer researcher, and so I'm big into the molecules. So the last part of that powers of 10, that's the part that gets me every time. And I am privileged to be able to study molecules. I love molecules. They're the coolest things I've ever encountered. They make up, when I think about what they make up everything that we see around us. I just did a chemical reaction, and not only that reaction, through the passing of electrons from one atom to another atom, leads to things like light. That is cool. And that is what gets me excited about science. I get goose pimples. I want you to see it right here. I am not kidding you. This to me, you know how people go to the Grand Canyon and they got all these pictures and they want to show you their slideshow? Well, I'm going to show you mine. And mine's going to be about molecules. Okay? So first I want to kind of think about what is science. It's a bit of a thing. Now, just want to remind you, I believe I have a track record here. I've been reasonably successful as a scientist. I've published my work in peer-reviewed journals. I've brought in well over $1 million in grant money. I have 2 patents. I'm a scientist. I'm a practicing scientist. I'm not a person who reads about science and pretends to be. I am one. So I can speak as a scientist. Now, I'm not saying, I don't think I'm anything special. I'm just saying I have the credentials to speak as a scientist because I do science. So that's what is science? And I just decided to look it up in the dictionary. Because I could not come up with a good set of words. So I just used the dictionary, and I'm like, that's exactly what I would have said. It sounds so good that way, too. So the intellectual and practical activity encompassing the systematic study of the structure and behavior of the physical and natural world through observation and experiment. So it's the study of it. And it doesn't say that it is going to figure everything out. It's a process. It's a growing process. And so that brings up a big point that I want to prove versus disprove. Science actually does not do either of these. Some people say it disproves things, but I argue no. Science doesn't really prove things. And in a like way, you don't disprove things. We are a bunch of Coco the gorillas, okay? And we're coming into contact with things that mystify even the most brilliant of brilliant people. Einstein did not believe in quantum mechanics.
Yeah, you know what he said?
He said God does not roll dice, does not play dice. And I read about it. It doesn't necessarily mean that he believed in God, it turned out. But what it meant is he thought everything should be so ordered and so perfectly ordered that the one piece of quantum mechanics that said that there's a lot of probability. You can never know where an electron is at any given time. You only could guess where it is, essentially. It's called the Heisenberg uncertainty principle. And so that exactly. So he had trouble with that. And eventually, he came around. He kind of bought into quantum mechanics, and quantum mechanics gets at the math and of the atom. And then later on in experiments, they can actually predict certain things and then see them happen. That's the wonder and beauty of science for me, is you can actually predict something. I knew that was going to happen. That's awesome. And it has never not happened, yet. Of course, if I did it wrong, I suspect it would have. So what science tends to do is you make these observations, and you come up with questions, and you try to come up with explanations for the things you're observing. And you build models to try to account for things. And I'm going to bring up one model. I'm not going to go over it. I am going to bring up the model of evolution. Evolution is a model. And I know, here's where I get in trouble. I know that lots of people, and I've been in all kinds of churches, where they have people debate against scientists about evolution. And they try to disprove it. And that doesn't happen. That's not even a scientific goal. The scientific goal is one of model refinement. If you find a mistake in a model, you fix it. You try to come up with a refined model. It's a continuum. It's not, you're never going to be able to disprove something. We're just a bunch of apes. Darn floor. Big. Well, not big bite. Bad bite. So I just want to make that distinction. For me, it's about modeling. Now in math, you can prove things. That's why, they're lucky. They can prove things. My son is an ace at doing proofs in geometry. You can bisect an angle. That sounds like something you had done, right? Then you can find out which angle is going to be the same and all that. You can prove it. There is no argument. Science isn't like that. In fact, some of my best discoveries were accidents. I thought I knew. I made predictions. I set up the experiments. And things happened really cool, but not the things I thought they would.
Serendipity.
Amen, brother. That's exactly right. And a lot of science progresses that way. So I'm just a big ape blundering ahead trying to understand this stuff. So here's some thoughts I had about science. Sort of, what do we get from it? We can get some understanding and knowledge of the physical world and natural world around us. That doesn't mean our understanding and knowledge is just facts. It just means we get a better appreciation for what it is. It's constantly moving. I, in grad school, spent 2 weeks learning about how a protein folds according to a certain model, and then the next week, a paper came out and refuted the whole thing, and definitively refuted that whole thing, and it changed the model. So I just spent a whole bunch of time understanding and developing knowledge in something that probably wasn't correct. But I refined my thinking, got me thinking, and I learned a lot from the process. Applications come from science, medicine, technology. Think of all the technology I'm now using. This laser pointer right here, be perfect. Curiosity and amazement. I work with kids all the time. When I showed them the powers of 10 at an elementary school, it's different. When adults see something that kind of gets their attention, they're quiet. Kids, ooh. And in fact, if they're quiet, I'm assuming they don't care. I heard them talking, they're whispering back and forth. That is so cool. Did you see that? That's a moon. We just got mooned. And it makes you, stimulates you, wants you to ask more questions, learn more, dig deeper. And in my case, it leads me to worship. And that's something that not every scientist shares, but that's my connection. That's how my faith and science overlap for me. Because I have the amazing privilege of learning God's creation at the molecular level. Atoms, interacting, moving. Now I understand that maybe not everyone in this room would do that, and I'm already telling you, I'm starting from a place of for me, I have faith in, I can tell you it's too complicated to necessarily get into now, but afterward, if you want to talk to me about it, why do I believe in things like that, I will need some time to formulate words, one after the other, and make sense. But I'd be willing to have that discussion. But for me, I'm just saying, science doesn't have to be at odds with my faith. I get to see the coolest stuff ever. Many of the people in the world, not none, but many of the people in the world don't. It's an amazing privilege. So I want to talk to you about water. I'm going to make you do some chemistry. And you'll see where I'm going with this. So I have to say, I'm not going to make you do this, Danny, but Danny's in my class. And we're doing this same thing. We're talking about hydrogen bonding, right? So is this accurate, what I'm saying? You got the polar water, right? You got a dipole. You got an uneven distribution of electron density, permanent, so it's got a permanent dipole. There's a partial positive charge and partial negative charge, remember that? Okay. And then it interacts through an electrostatic interaction, remember that? See, he's going to be okay. All right. So water, H2O, and molecules are not made of letters. So we have two H's and an O, but that's not how they look. They look more like this Mickey Mouse looking thing. Maybe closer to that, but not even that. Again, that's, how can I put it? That's a painting of an earthquake done by a monkey. Okay, this is our best tries right now. I have to say some of our models are better than I thought because one of the things I've recently found in the last, as we get better and better in our technology, I've actually seen a molecule with the atoms and everything, and it looked just like how I drew it. It was blowing my mind. No C's though. No C's, just H's. So anyway, so water has 3 atoms, and those atoms are arranged in such a way that they can interact with another water molecule, and it holds them together. That's why I have a cup of coffee, which is also made of water. Let's pretend it's just water. I can pretend. And the water stays in the cup. Some of it. Some of it does evaporate, but for the most part, it stays liquid in the cup. And that's because the water molecules are attracted to each other. Much like magnets are attracted to each other. Again, North Pole, South Pole. And this, in chemistry, we don't really talk about North Pole and South Pole. We talk about positive and negative, but it's the same idea. We even call them poles. So they have a dipole. They have 2 poles, negative and positive. Negatives like positives. So in water, they're interacting. They're holding together. All right? And so, I don't know if you ever thought of this, but ice is also water. Some people don't know that. Dihydrogen monoxide, in fact, is water. And it's actually a pretty funny video you should watch someday. There's a swear in it, so I'll just warn you, PG-13 warning. But they walk around getting people to see if they want to ban dihydrogen monoxide. This is what they say about it. It's in our lakes, in our rivers. It's in our baby food. You can't wash it out of your food. And all these people are saying this position, oh yeah, let's get rid of this.
MSDS.
Yeah, well, that's a different story. With the MSDS, it's very funny. MSDS is called Material Safety Data Sheet, and it's what we use to tell us what's dangerous about a chemical. But if every chemical is like death. And so you can get a Material Safety Data Sheet for water, and you can, and I've showed it to Matt. And you know what you do if you get water in your eyes, what you're supposed to do? Flush it with water. That's what you do for the rest of your life. Because keep putting water in your eyes. Now you got to use more water to wash it out. Never-ending process. So water is awesome. And the water cycle is awesome. So here's the big picture. You may have seen this in grade school, junior high, wherever it was you saw it. You get the idea. We get liquid water, evaporates, becomes gas water. And gas water goes and starts to condense, becomes liquid water again. And it rains, liquid water. sometimes it comes down as snow, solid water, ice, doing all that stuff. And so, at the molecular level, this is what's happening, okay? Turns out, water molecules that are gas aren't attached to any other molecules. They can go wherever they want. They're unattached, and when they come closer together, every now and then, if they get under a certain condition, usually it's something, oh, I really want to ask you a question, but I'm not going to. Okay, you lower the temperature, what do you lower? What am I doing?
Oh yeah, the movement of molecules.
Yeah, the kinetic energy, movement of molecules. And so as you slow them down, they start sticking together, and they see each other again. So here's liquid water, and when ice forms, it forms these really well-defined crystalline structures, and that's all because of the hydrogen bonds that hold them together. So this is the water cycle at the molecular level. And you can walk on ice, but not necessarily liquid water, unless you're Jesus. And we'll talk about that. And I thought, this is something. This is called a molecular dynamics simulation of water. And I'm going to show you what it looks like at the molecular level for water as ice. I got to just bring this over here. There's no sound. So I'm just getting this to the point. So it's just kind of showing us, here's ice, okay? And it's going to show you a molecular dynamics simulation. So molecules are moving constantly. A great physicist, Nobel laureate, Richard Feynman, one of my favorite physicists, I actually have one. And he says, this is how he says, the world is a dynamic mess of jiggling things. And you'll see that here. Okay? So this is, they're just kind of showing you, this is like an ice cube, a really, really, really small one. So now the water molecules are jiggling. And you can see on the ends here, you're starting to see melting. You'll see melting go from, melting is the process of going from solid to liquid, okay? So ice is very ordered, very solid. Everything's holding in place. They can't go wherever they want. They don't flow. You ever notice that about ice? They don't flow. They'll make you flow when you slip on it. But at the ends, they're starting to wiggle around. They're going to lose some of their structure, okay? They're going to lose some of their structure, and they're going to wiggle and begin to melt and fall apart. And the interactions are changing, and that's what melting is. And so this stuff's moving, and you can see it's starting to degrade on the edges as melting happens. These are molecules and atoms wiggling like crazy and melting. And I wasn't kidding. So how does that impact me? What about that makes me think about worship, about better appreciating God and what He did as a creator? Well, as I look here, I thought about walking on water, and it got me thinking. That's a miracle, unless it's ice. I drove a car on water that way, I guess. But no, if this story is essentially Jesus was walking on water. And not only was Jesus, but eventually Peter did until he realized, oh boy, what am I doing? And then he fell and got wet, got soaked. But I started thinking, the molecular mind going, does that mean that every one of those atoms are at God's command? Did Jesus command a phase transition? I don't know if He did, but just give me some thought. Water molecules, do what I say. Or He could have changed His own molecules. I don't know what He did. Suspend some of the physical laws, all of them, or make them work for Him. I don't know. But boy, do I have a different look at this parable when I think about what is happening in the molecular world, God's molecular creation. So I thought of this in the shower this morning, actually. I didn't plan to talk about this until Well, I was taking a shower. Good thinking. There's water. Got me thinking about water. Easy walking on water. But one of the big challenges for me is I wanted you to see the things that just get me. Give me those goose pimple moments, but more than that, drive me to my knees. Worship the Creator. Give me something that I can really sink my teeth in. The other thing I want to just kind of point out, and it's a little bit nerdy of me, but this is my research. So I'm going to talk about my research just a bit. This here, what you see here, looks like a chewed up hunk of gum. Maybe there's one underneath here, I don't know. But this is essentially, this is carbonyl reductase. It's the name of an enzyme I study in my lab. And it has all these little shapes, nooks and crannies, and there's a little small molecule that lives right there. And that small molecule is a drug. And that drug binds there. It held in place through the same kinds of intermolecular forces that hold the water together. Similar types. Really amazing stuff. That's how your drugs work, actually. They float through your body, and they find a protein, and they bind to it. They might bind to DNA too. They bind to it, and they create some kind of response. Every molecule holds a ton of information that only the other molecules know how to decode. It's still a mystery to us. We're trying. I do drug design so that we can get certain properties to happen so I can get improved chemotherapy drugs and the safety of them and stuff like that. And we've been successful. But it's like that. I'm like the grill. So I just want to show you that, and I'm just going to show you real quick something. One of my students made a molecular movie of our enzyme. And so I'll show you in all of its beauty. It's going to rotate around and show you the active site where the molecules bind. Ah, it's like my baby. I don't have pictures of my kids in my wallet, but I got pictures of this molecule. All of those colors depict a charge. I talked about charges before, positives and negatives. Blues are positives, negatives are reds, and the whites are kind of neither positive nor negative. And now inside here, these are where the drugs bind, and they create some kind of a biological response in the body. And that's a lot of how drugs work. To me, that's amazing. In my research, boy, I'm really going to pull this one on. I'm almost done, so don't worry about it. Just sleep the rest of the way if you need to. These are molecules that my lab has discovered as potent inhibitors, they're called. And in fact, when we give some of these, this one for instance, when we give this to cancer cells in the presence of other chemotherapy drugs, we improve the strength of the chemotherapy drugs by 5-fold. You need five times less. And so we're like, how do we unlock this mystery so we can even make better ones? And so one thing we do is called structure-activity relationship studies. That's a medicinal chemistry thing. And we just start shoving things. So what you need to know into there, and not just shoving them like, ooh, I'm going to push you. We start shoving things into our enzyme and see what fits and what doesn't. We can actually measure it in my lab. Max has. Didn't know what he was doing, but he did. Proud of that boy. So one of the things we want to do, every one of these corners is a carbon. You've heard of carbon before, probably. If you didn't, that's okay. I still love you. O's are oxygens and H's are hydrogens. So one of the mysteries we had is we kept seeing that this and this did not bind very well to my enzyme. We were surprised. We didn't know why. But then as we made longer carbon chains, it got better and better and better. And we broke 3 world records for the best known inhibitors at Boise State with undergrads doing my research. Blows my mind. And it's cool. I have to say, I'm really proud of the students we have at Boise State. I have to say, it's quite an honor to work with them. Even when I have to fail them sometimes. So we did molecular modeling. This was done by one of my undergrads. I don't even know how to do it. He had to make a picture, so I used it. So he built these models, and they use quantum mechanical, computational, computer type things, and they try to figure out, this is the same, these are the molecules that we're looking at, and we were trying to figure out, why is it that this thing, when we grow it bigger, it gets to be a better inhibitor? And what we found through this study is, right now that thing's just kind of dangling, it's making some contacts, and some of those attractive forces are holding it in place. And then we started digging deeper, and we started realizing that there's a little trench right here, and the molecules start filling into that trench, and that's their whole, it's like a lever being held onto, so they're held onto better, and they're more effective at what we're looking at. I realize you may have no idea what I just said, and that's okay. But I hope what you can see is that there is some detail to this universe, and as big as it is in one direction, it's that small in the other direction, and the universe is full of atoms, full of them. And I don't know why, I can't tell you why, but for some reason, those are the building blocks that God chose to make the world. And as a scientist, I'm privileged to be able to get a grasp, get a handle on some of that stuff. It amazes me. So, I'm a work in progress. I have more questions. These are some of them. How did God create the earth? And that's where I admire looking at things like evolution. I'm not afraid of it. And I actually see there's a lot of merit to it. And that's where I get in trouble with a lot of people in church. Not that I would challenge that God created the earth. I don't. I accept it fully. What I know is that he did. How he did, I don't know. But science gives me some chance. And remember, we're just a bunch of apes. Darn floor, bad fight, trouble. Are there really black holes? I just read a paper by Stephen Hawking, one of the greatest physicists of our time. Just came up to the conclusion that his idea that there are black holes is wrong. Now we don't know if they are. And I read it, and I had no idea if that's what it meant or not. But I want to know. And then there's some ideas at the physics level, and this is amazing how internally and how consistent many things are. Some of the same stuff we use to predict what happens in the universe can actually sometimes be connected to what's at the level of the atom. But there's still some disconnect, and so there's this idea, is there a mathematical model that can cover it all? That would be kind of cool. I'd love to know that. And how small does matter go? I first got interested in science when I was in 3rd grade, and I looked through a microscope. And I realized that ants had hairy legs. Like some of you probably. But I realized there's some detail to this world. And then as a chemist, oh my, blow the doors off. So I want to know that. What science is to me is to actively engage. It means for me to actively engage with the molecular world, which really, how can I put it, toots my horn. It's a better way for me to appreciate the depth and breadth of the Creator. Not the creation. I don't want to worship the creation. But I learned something about the creation. And molecules make me want to worship. Not many scientists say that. So that's really all I have to share with you, and I appreciate your attention. I have no idea how long it. Well, it's only 8:01. It can't be that bad. I've talked longer than that, haven't I, Danny? So at this point, I don't know if you have some questions, thoughts, comments. I can't promise an answer. I'll just promise I'll listen. And in 4 or 5 days, I'll email you. So thank you.
Just a fabulous talk.